All right, so all right, ladies and gentlemen, let's look at our answers to number 1. So we have the y-intercept, which is at 0, 1. And then we have our key pieces of at 0, 1. The axis of symmetry, which is at x equals -1. Our vertex, which is -1, 0. You have a min at 0. You have roots at x equals -1. These are considered repeated roots because that vertex lies on the x-axis. In your table, you have -1, 0, 0, 1, -2, 1, and then that pattern would continue. It would be at 1, 4, and -3, 4, and so on and so forth. It would then jump to 9, etc. So, you would plot your points. Again, I am really looking for the roots this time, but that doesn't mean that we're not focusing on other parts of the problem as well. Number 2. In number 2, we have a little bit of a unique situation because now my roots are not perfectly aligned on that graph. They're going to be between 2 points. So when you give your answer, you need to make sure you give that your answer is between a -1 and 0 and a 2 and 3. Your y-intercept is at 0, -3. Your axis of symmetry is at 1. Your vertex is at 1, -6. You have a min at -6. And then number 3, your axis of symmetry is at 0, -4. Your y-intercept is at 0, -4. Your axis of symmetry is at -2.5. You have your vertex at -2.5, 8.5. That is a max because my graph is open down like a frown. Your roots are between -1 and 0, as well as -4 and -5. Okay, on the back, we have a few more examples. So once again, you want to focus on those 5 key points: y-intercept, AOS, vertex, max or min, and roots. You'll probably be happy to know that starting on Thursday, we're moving away from graphing and into factoring, because I know how much we love graphing. So tomorrow's quiz will be our last assessment on graphing. Okay, and then number 5. This example has no roots because the graph is completely above the x-axis. So this graph has no roots because it's completely above. It is symmetric about the y-axis, or x equals 0. Its vertex is 0, 5 because the graph is shifted up 5 units. It has a min and then 6, 7, and 8. In 6, 7, and 8, you needed to look at your table. And when you were looking at your table, you were simply looking at where did we have a sign change. So at -2 and 1, it goes from a negative to a positive on y. So that is a sign change. So if you have a sign change on y, then you have a root between on x. So you look for a sign change on y to give a root between on x. And then at the bottom, looking at our graphs and being able to identify if we have solutions, and if we do, how many and where. Questions, comments, concerns, anything you think you want to see or go over more in depth? Can you construct a table like 6, 7, and 8 on your own? So if I gave you x, f of x, and I asked you to create a table, are you able to create a table for me that would give you those values? Okay. So what I want to do is kind of review with you today different thought processes about this. So originally I was going to maybe do Jeopardy, but I am thinking about maybe doing a handout with you instead, because I think we can benefit more from looking at some practice. So look at the 3 examples up on the board and determine in those 3 examples how many solutions each one of those graphs have and where those solutions are at. So again, you're looking at each of those 3 graphs. You're determining how many and where they are. So looking at each of those 3 graphs, determine how many and where they are. All right, so looking at that first problem, I had told you look at them, determine the number of solutions. So in that first example, the graph crosses the x-axis twice. Therefore, in example number 1, you have 2 solutions. And the solutions are at those x-intercepts. So that's at -3 and +1. So you have 2 solutions at -3 and +1. In the second example, you have what we call a repeated root. The vertex is on the x-axis. Therefore, that is 1 solution. And your solution is at the x value, -3. And then in example number 3, that graph never crosses the x-axis. If a graph never crosses the x-axis, then that is no solution. Okay, looking at examples like 4, 5, and 6. So these are the ones where we would create our table, and that's where I was kind of showing concern on my end is, can we make that table? Can we get a graph from that table? And can we interpret that? So if it didn't have you graph, but it simply had you create a table, are you able to take that idea of x squared minus 6x plus 5 equals 0 and construct a table for it? So what you would do is find your h and k. So your h and k are 3, -4. That represents your vertex. So my vertex is at 3, -4. So in order to get a table of values, you would put your vertex in the middle. And then you're still applying your x plus h, y, a plus k. It's just that you're looking at it turned sideways. So this is my x plus h. So that's 0 plus h, 1 plus h, 2 plus h, 3 plus h. So you get 3, 4, 5, 6. And then down here, this is still my YA plus K. So that's 0 times A, which is 1, plus K, which is minus 4. 1 times 1 minus 4. And then 4 times 1 minus 4, and it would be 9 times 1 minus 4. So this is still my ya plus k, it's just down on the bottom. So it's negative 4, negative 3, 0, and 5. And then the table is symmetric. So what that means is whatever your y value is to the right of the vertex, my y value is to the left. So that then goes negative 3. After negative 3 is 0 and 5. And since my x's are increasing by 1 to the left, they decrease by 1. So I could plot those points or look at my table and say, okay, I have a 0 in my table at 5 and 1. So what that means is that my roots are at x equals 1 and x equals 5. So if you have a 0 in your table, those represent your roots. If you have a sign change and no 0, then your roots are between. So a 0 in your table gives the roots. A sign change with no 0 gives roots between. Let's take these table values and plot them as points on that handout. So we said our vertex was at 3, negative 4. So we'll plot our point at 1, 2, 3, 1, 2, 3, 4. And then we had our next points at 4, negative 3. And then we had a point at 5, 0. Which meant we also had a point at 1, 0. And then we had a point at 6, 4. Or 6, 5, sorry. Can't add. And 0, 5. Okay, number 5. So once again, find your h. So we get negative 2 over negative 2, which is positive 1. Find your k. So negative 1 plus 2 is 1. 1 minus 4 is negative 3. So my vertex is at 1, negative 3. The negative in front tells me my graph opens down. We also call that reflected. An h value of 1 told me right 1. A k value of negative 3 told me down 3. So again, just reviewing those transformations we talked about before. If my graph opens down and my vertex is below the x-axis, my y-intercept is 0, negative 4 because it's the c value. So that means I have a point here, and my symmetric point is there. Okay, so here's my graph. Oh, that was kind of very off my points. Is my graph ever going to cross the x-axis in blue? Is it ever going to hit that graph? Is it ever going to hit that line? No. So this has a no solution. No, yes. Yes. Okay, let's look at 6. I'm going to put you guys to work in 6. Okay? So, let's just go through and I'll randomly pick on kiddos. What is my A value? What is the value of A? And if you know it, I'll take a hand to start, but after that, all right, Nick, what's A? 1, good. Okay, Nick, popcorn a friend. We're all going to go, so it doesn't matter. Okay, what's up? Can I do it when we're done with the lesson? We're in the middle of reviewing. Okay, what's the B value? Who'd you pick on, Nick? All right, what'd you get? Awesome. Pick on someone. What's my C value? Good. Okay, H is always equal to negative B divided by 2A. So you picking on? Okay. Micah, what is my H value then? Good, it is 3. Because it'd be a negative 6 all over 2 times 1, which becomes a positive 3. Excellent. Who are you picking on? Okay, what's my K value? I'll give you a minute to plug it in if you need it. Three squared is, okay, and then 6 times 3 is, oops, yeah, 18, plus 4, should be negative 5. Watch how you type in your negatives, I think. Okay, so we get negative 5. So my vertex is at 3, negative 5. So you put that in the middle of your table. And then you do your 0 plus H. 1 plus H, 2 plus H, 3 plus H. Then you do your YA plus K. So that's 0, 1, 4, and 9. All times A, which is 1. Minus K, which is 5, minus 5, minus 5, minus 5. So you get negative 5. 1 times 1 is 1. 1 minus 3, 1 minus 5. It's negative 4. 4 minus 5 is -1, and 9 minus 5 is 4. So, my table is symmetric. Ryan, pick on someone. Okay. Miss Bella, what would the point to the left of 3, -5 be, since this is symmetric and decreasing by 1? So what would this point that goes in this space be? Yeah, 2 for x, and then what would the y value be? You don't know? Okay, so if my vertex is here, the y value to the right is the same as the y value to the left because of that axis of symmetry. So it'd be at 2, -4. Okay, pick on someone. Colton. She did. What would the point be to the left of that point then? So if I have 2... Very good. Okay, and pick on someone else. Very good. Awesome. Okay, so does my table have a 0? Well, yes. Okay, does my table have a 0 in the y values? No. So my roots are going to be between 2 points. So where are my roots? Reese, go ahead and pick on one last person.
-4, -5. Wait, no, 2 and 3. Wait, no. 0 and 1.
Very good. I have a root between 0 and 1. And I have a root between 5 and 6. Okay, that's probably going to be the hardest question I think you'll see tomorrow. What, honey?